today's problem is find the punishment number of an integer. So we are given that I can be 1 to n, all inclusive. So I is our integer, and the logic that they have given us is that the decimal representation of I square, if partitioned, and if we do the sum of the partition, it should be equal to the root of that number, which means I. So basically, if I say 36, so the square of 36 would be 1296. Now if we partition 1296 as 1, 2, 9, and 6, we will have 18, which is not what we are expecting. What if we partition it as 1, 2, 9, and 6? We will have 36, and that is what we are expecting. Now to approach this in a brute force manner, we'll just run a loop from equal to 1 till smaller than equal to n, because it's inclusive of n, and I plus plus. Alright, so I will take one more variable, which would be sum, just to maintain the sum. And here I will check if it is a number which has the sum of partition of its square as itself. So for that I will write a method which I will call checksum or square or whatever, and I will give it I and the square. So before that, let me just calculate the square as well. So square would be I into I, pretty easy. We're going to pass square, and I square and I. So if it is a sum, we are going to sum plus equal to square. So we are just going to add the square to the sum, and in the end we are going to return. Now the tricky part is how will we partition the number. So if we think it in an iterative manner, for example, if we have this, so we can run two loops. One can start from 0 till the end, and second one would be from index of the first one till the end, and we can compare. But the problem here is that there can be many partitions, and the size of partition may vary. So therefore, we are going to use a recursive approach. And for that, I'm going to first write this checksum function. So public static boolean checksum be int I and square. Alright, so I will name this num. And here I'm going to call my second number. So I'm just going to do return. Sorry, I'm just going to call my second method. So I will call it check in part, check partition, check part, and I will give it the square of the number. So string dot value of square. I'm going to give it index. So that would be 0. And then I will have another variable to maintain the sum and then the original number. So the num. Alright, so now to write this check-in part, I will do public static boolean check part. So we are just going to have the signature same as the call that we just wrote. So int index and current sum and the number itself. So since this is recursive, we are going to have a base case, and the base case would be if index has reached the length of the square, then we are going to do return if current sum equal to number. So here we will have our answer. So now I will write our partition logic. So I think of it as running a loop as we decided from index till the length of a square, and here we will check if we call the same function recursively. So square would be square, so index would be j plus 1, so that would be the next index, and then we have the current sum. So current sum would be, okay, before that I'm going to take a substring. I will maintain the sum equal to square dot substring. So I will take it from index till j plus 1. So in case of 1296, for the first iteration we will have 1296, 0, 0, and 36. So when we are calling it for the first time, we will get substring as, so the sum would be, so j is the index and we are calculating it 2 plus 1. So it would be 0 to 1, which would be 1, right? And then we are going to call the check part again with 1296. So the new index would be j plus 1, which would be 1. Current sum would be 1, and then the original number, which is 36. So in the next iteration, it would take substring from 0 to 2, but before that this call would be executed, and it will give us 1 to 2, which would be 1 and then 2, and then it will sum, it would be 3, and it will keep going on. So coming back to our conditional, so in this call I'm going to pass t plus 1 as the index and current sum as the sum, and we have number as number. So if this returns true, means we have reached our number, and we are going to return true, else we are going to return false. So let's see the time complexity for this one. Oh, I missed a lot of things. Okay. So that is the only problem, I hope. Run. Oh, sorry. A bit of an oversight. So it is going to be integer.parseInt. We're going to parse it as an integer. That should fix our problem. Wrong answer. Output 62. Expected 182. Why this happened? Oh, actually, because we are not adding current sum. Alright, so our sample test case is accepted. So we are going to submit, and let's see. So the solution is accepted, but it is not ideal because we have a huge runtime. We are somewhere in the middle, and the best solution has 2 millisecond of runtime, and the best solution has 44 MB of memory. Alright, so I'm going to optimize it a bit more, and I think we can use an array to store the computation of the punishment number so that we are not calling this logic over and over. So we have already seen the brute force approach to this question, and now I'm going to optimize it a bit. So to do that, I'm going to introduce a static variable. So it would be an array of integers, and I will call it pun array. And since in the constraint we are given that at most there would be 1000 and 1000 numbers, so we are going to take 1001 as the size. Alright, so now I'm going to pre-compute the numbers so that we can store them in the memory, and we will just fetch them once. Now I'm going to use a static block. So in Java, the static block executes when the class is loaded into the memory. So this will execute only once, and it will save a lot of time in our execution. So I'm going to run a loop from 1 to 1000. We are going to call our checksum. So if checksum I, comma I star star, I star I, which would be square. We'll take square equal to I star I. So if this gives us true, we're going to set array I to square. Else we will set it as 0. Alright, so now I'm going to run this loop one more time. And I'm just going to add the previous element. So I'm just going to do one array I equal to one array I plus array I minus 1. Now we are going to do a slight change. So instead of all this, we will just return an array n. And now let's see. Okay, wrong answer. Oh, sorry. So this has to be an else. All right, let's see. And perfect. Just click on submit. So we have beaten 98% of solutions. So we're still not the best. There's room for improvement, and I believe it is because of this loop. We are not doing good. So we can optimize it a bit further and we will see how. Alright, so to optimize it further, I have changed my recursion logic. So here what I'm trying to do is, so this part is going to grow our number. So for example, if we have 1296, it's going to be, so let's say in the first call it goes 1, then it will check 1 2 and also 129, also 1296. So the first one will do this, while the second one will go like this. So it will go 1 2 9 6 or 1 2 9 6. So it will take individual digit at a time, and this should work more efficiently. So I'm just going to run this. And our runtime is much less now. Let's see if we submit. And now we have beaten 98% of solutions. And also the memory wise, we are now much better.